Today we will solve the problem 3.36 of Griffith third edition Introduction to Quantum Mechanics. Uh, Problem 3.36 is, suppose we have the wave function psi of x0, which is equal to a divided by x squared plus a squared between the limit minus infinite to plus infinite for a constant a and small a. Determine the a by normalizing the wave function and find the expectation value of x squared sigma x at time t equal to 0. Now we will solve one by one. First, this problem contains 5 parts. We will solve the part one by one. First, two part. For this, please, for normalization constant, please refer my lecture on Griffith third edition, problem 8.2. The normalization constant can be found in usual way, which is here it is 2 cube divided by pi. So a is equal to capital A, that is normalization constant is square root of this one. So a cube can be written as a square root of a, and this 2 square root of 2 and pi square root of pi. Now we have to find the expectation value. For that we need modulus square of psi, which is equal to this square of this wave function, that is a squared divided by x squared plus a squared whole square. So now by definition, the expectation value of x is equal to integral between minus infinite to plus infinite x multiplied by this modulus square of the psi of x with respect to tx. So now this can be written as modulus a squared integral. uh, I have taken modulus a squared outside because this uh, modulus psi squared is equal to a squared divided by x squared plus a squared whole squared, and here I have taken x as it is. If you see this denominator, that means the wave function is even function. So the expectation value of x is an odd. This is odd integrand. So naturally, this will be equal to 0. Now we will see the expectation value of x squared. By definition, the expectation value of x squared is equal to integral between minus infinite to plus infinite x squared modulus psi x of 0 squared tx. Here I am changing the limit of the integrand from minus infinite to plus infinite by 0 to infinite. So there is a multiplication factor 2, and modulus I squared is equal to you know very well that modulus a squared, which I have taken out, 2a cube divided by pi. This is the square of the normalization constant, and you have x squared and divided by this wave function x squared plus a squared whole squared dx. Now what I am going to do is I am going to substitute this. See here, this 2 into 2 will become 4. So you will get 4aq divided by pi. And here I am taking a squared outside here. So this will become a power 4. So then this will be x squared over a squared plus 1 you will get. Now you substitute this x squared by a squared as u. This is u. So u is equal to x divided by a. Then x is equal to au. You bring this a to the left hand side. So x is equal to au and dx is equal to a du. You substitute all these parameters here. That is, you can substitute. Already you have substituted x squared pi divided by a squared by u squared, and this x squared you have to substitute. X squared is equal to x is equal to a u. So naturally x squared is equal to a squared u squared. So I have taken that as. And tx, what is tx? Tx is a du. So a du. So I have replaced tx as a du. Now you can cancel some of the constants. That is, here you have aq. Inside the integral you have this a squared, and one a is here, and if you here you have a power 4. So this will become just a, because we are cancelling this a squared into a cube. So divided by a power 4 is a just. And also further this a also you can cancel it with this a cube. So which will become a square. So now you will get 4a squared over pi, integral between 0 to infinite, u squared minus u squared divided by u squared plus 1 whole square. Uh, Now the value of this integral, this value of this integral is equal to this integral. Value of this integral is 5 by 4. Is a standard integral 5 by 4. So now you have outside the integral 4a squared over pi, and the value of this integral is pi by 4. Now pi and pi will get cancelled, and 4 and 4 will get cancelled. You have only left with a squared. Now what is sigma x? By definition, sigma x is equal to square root of expectation value of x squared minus expectation value of x whole squared. We have seen this expectation value of x is 0, so this will be 0. So naturally sigma x is square root of this expectation value of x squared, which is nothing but a. We have found the sigma x. We have to find the sigma p also. Now, section C is find the momentum phase wave function pi pi of p0 and check that it is normalized. So, in order to find transfer the position phased wave function to momentum phased wave function, we are using the Fourier transformation technique. Fourier technique, which is by definition is pi p of 0 is equal to 1 over square root of 2 pi h cross integral between minus infinite to plus infinite e power minus I px over h cross psi of x0 tx. Now you can replace this psi x of 0 psi x of 0 by the wave function, this one. Wave function by definition is 1 over x squared plus a squared. Of course, you have normalization constant a. We know the normalization constant is a square root of 2a divided by pi. This will become, we can rewrite this x squared plus a squared as x plus ia into x minus ia. You will get this. Now you can do the residual integration, that is contour integration. Here you can see when x is equal to ia, this will go away. When x is equal to ia, this will become 0. So this is a residue. So you can ignore this term. You can, in fact, This term is a residual term. Then what is residue? Residue is e power minus, I am taking that e power minus I px over h cross x plus ia. You will get the residue when x is equal to ia, this term. So you ignore this term. So then residue when x is equal to ia is equal to this exponential term. Here you replace x by ia. So ia plus ia, you will get 2ia. So here we can reduce some of the constant outside the integral. So what are the terms you can cancel? This 2 square root of 2 will get cancelled with this square root of 2, and this square root of pi and square root of pi will become pi. So that's what I have written, and I have taken a as it is. Square root of pi into square root of pi is pi, and here you have one square root of a and h. Square root of a and square root of h, because I have taken this square root here, which will become square root of pi into square root of pi is pi. So square root of a divided by square root of h cross, and this residual in this residue is this one. So according to contour integration, this value of this integral is 2 pi I times the residue. 2 pi I times the residue. Here residue is this one. Now here you can cancel this 2 pi ia. See, 2ia, of course with pi, 2 pi ia. So 2 pi I will get cancelled. Here you have a. This is also will get cancelled. So ultimately you will get the square root of a divided by square root of h and this exponential term. So square root of a divided by square root of h and this exponential term. This is a momentum based wave function. Now we got the momentum wave function. Momentum wave function is equal to square root of a divided by h cross e power I modulus pa over h cross. Now our task is we have to find whether this is normalized or not. So now I am changing the limit. Instead of minus infinite, I am taking this as 0. So naturally one multiplication factor 2 will come here. So I can take 2, then the square of this wave function. Square of this wave function is a over h cross, integral between 0 to infinite. This e power minus, if you square this, 2 modulus pa over h cross. You are integrating over p. With respect to p, you are doing integration. So if you do this integration, you will get this exponential term divided by 2a over h cross, because you are differentiating with respect to p, and this limit is 0, between 0 to infinite. So here this 2a over h cross will get cancelled with this 2a will 2a divided by h cross. You have this minus 1. So that can be taken as minus 1. This is minus 1. Now you apply the limit for the numerator. That is numerator. Already you have minus 1. If you apply maximum limit, e power minus infinite is 0. Then minus the lower limit, e power 0 is 1. So this will become minus of minus 1 is equal to 1. So this naturally this wave function is normalized. Now use pi of p0 to calculate p squared and sigma p at time t equal to 0. Now the expectation value of p, naturally you expectation value of p is equal to p that modulus square of this wave function, momentum based wave function, which is a over h cross e power minus 2 modulus p a over h cross dp. So add integrand naturally is equal to 0. Even otherwise, the p is equal to the time derivative of expectation value of x. We have already seen the expectation value of x is 0. So naturally this expectation value of p also equal to 0. Then what about p square? Then p squared, you change the limit from minus infinite to plus infinite as 0 to infinite. One multiplication factor 2 comes here, and p is replaced by p squared because we are going to calculate the expectation value of p squared. So this is p squared e power minus 2 modulus p a over h cross squared tp. Now we will solve this integration. So we got this integral. Here you can see this is a gamma integral, that is integral between 0 to infinite p power n e power minus p tp is equal to gamma n plus 1 divided by p n plus 1. Here you can see this n is equal to 2 because it's p squared, n equal to 2. Then what is p? This p is equal to, see here it is minus p, except this modulus p, everything is p. So 2a pi h cross, 2a pi h cross. Then p n plus 2 means 2 plus 1, 3. So pq is equal to 2a divided by h cross whole power 3. So you substitute this here. So if you substitute here, you have already 2a over h cross. N plus 1, comma 3 is equal to 2 factorial, which is just 2. And we have seen pq is equal to 2a divided by h cross power 3. Here you have already 2a divided by h cross, which will get cancelled with this cube. It will become square. So you will get 2 divided by 2a over h cross whole square. So if you square this, you will get h cross square divided by 4a square. Already there is 2 in the numerator. So this 2 and this 4 will get cancelled. You will get simply 2. So you will get final result as h cross squared over 2a square. This is expectation value of p square. Then what is sigma p? Sigma p is equal to square root of expectation value of p square minus expectation value of p whole square. As usual, the expectation value of p is 0. So naturally you have to take square root of this. So this will become h cross divided by square root of 2 into a, because this is a squared, it will become a. So now the question E is, section E is, check the Heisenberg uncertainty principle for this state. So that is sigma p into sigma x. So sigma p we have seen h cross over square root of 2a, and sigma x already we have seen sigma x is a. So this a will get cancelled. So you will get h cross over square root of 2. Definitely this is greater than or equal to h cross by 2. So we have verified the uncertainty principle. Thank you very much for watching my videos and supporting me continuously.